Okay, recording is started now. Okay. So today's problem is shortest path in binary matrix. So this problem is like a kind of standard problem that we face like to find the path. Like you might have heard about retinal maze problem, something like that. So we have one starting point and we have one target or ending point. So we have to reach from source to destination kind of thing. Like this is not working. Okay, so leave it. I was telling from source you have to go to the destination point. So in this problem, let me first explain you what the problem is. So given an n by n binary matrix, that is grid, this is our matrix. So return the length of the shortest clear path in the matrix. If there is no clear path, return -1. So and they are also like telling what is clear path. Clear path is like you are here at top left location and you have to go to the bottom right location, that is your target point. So you have to count like shortest path. So in that shortest path, they are calling it clear path. You have to count the number of zeros and return it. So all the visited cell of the path are zero and all the adjacent cells of the path are eight directionally connected. So you can go like in any direction, like up, like left, right, up, down, and also these corners four. Okay, like if I can use this, yeah. So like from here you can go in all eight directions. Okay, like this, 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 these four. These are we use generally. Like these four also we can use. Okay, so these eight directions we can use. Like we can go to find the path. Okay, so let's remove it. Yeah. So this is one test case. So let's see the test cases. This is the one. This is the first one. Okay. Yeah. So here we can see like from source extension we can go directly. So the cost will be 2 because 1 0 we can see at source and another one we can see at destination. Okay. Okay. This one is this one we can see. Okay. Like they are in the answer they are giving 4. How 4? Like 1 2 3 and then 4. But if we see another path, we can find like 1 2, like before moving here we can go to this last one. So 1 2 3 4 and 5. So in that case that is 5, but we have to return the shortest one, so we are giving 4 here. Okay. Last example, like in this example, if you cannot go from source to destination, like here the source is 1, but we know like starting point, like entire path should be consist of zeros. So if source is already 1, then how can we proceed from the source? So they are giving -1 in this case. So how can you approach this problem? First of all, generally in a beginner's mind, or like in my mind also, I thought of doing it with DFS. Okay, like but DFS, what the case is actually, uh, like DFS we use to explore all the paths. Like it will explore all the paths, then you can compare which one is shortest path. So this will take hell lot of time, so the solution will not get accepted. Let me show you. See, these three all I have tried with the DFS. So this not get accepted. Like some you can find, but like they are doing some customization, but that is not like a good practice, I can say. But to find the shortest path, BFS is like optimal. Why optimal? Because in BFS we go levels wise. It's not we will explore all the paths then we can compare, but in BFS we go levels wise. Like how, let me show you. Like from here, like suppose this is also 0, this is also 0. So what DFS will do is DFS will go like, let's suppose DFS will go here, it can go here also. But let's suppose I'm like we can take anyone. So like it will go here, then it will go here. I found one path. Okay, the cost is here 3 1 2 then 3. Okay, so like after returning this, it will explore it will go here, then it will go here. Okay, so like it will explore all the paths. The point is that, not, if not with this one you're confusing, then like you can try with yourself also. Like if we are exploring all the paths, it will take hell lot of time. But in BFS, what the thing is, we are going levels wise, as I like told before you. So the thing is, in the queue we will take one level at a time. So like we are finding the shortest path when we are traversing. So like when shortest path will come. How to frame it? Give me a minute. Okay, so BFS works level wise. So at the same time you will be searching and giving the shortest path. Like from here you will go. Okay, let me explain with the example. Hmm, see, from here in our queue, like from here I will, like from here this cell I have stored. So from this level I will go to this level. Like this is stored in my queue. Okay, so from here, uh, this cell and this cell, both cells will be in the queue simultaneously. Like all the paths I will be visiting same time. So shortest path I can give instantly. Like from here, if these two cells are in my queue, then when these two are in my queue, then I will pick this one or this one. You can take anyone, but when we are in BFS we have to take all these two. This is not like DFS we have this case. Like we can take one, we have to proceed like after, and then we can came and check. No, this time we can take both the cells and explore. Like we are checking every possible path at once and we are giving the shortest cost. Okay, so like these two cells are in the queue, then I have picked this one, and I see, oh, I reached to what your target. And then I can see like cost is what, like how many levels we have crossed. 1 2 3 4. So the cost is 4, my friend. Okay, this is how it is working. Let me explain you the code. So this is our code. Okay, so what I have written is BFS perfect for finding shortest path. As we have discussed, like we are going what you said level wise. I have already explained it. So okay, let me explain the code. Let me zoom in. Ta, 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 ta. Okay, not getting zoom in. The mouse has some problem, I think. Okay, we'll figure out later. Okay, so we are saying if the source is one, already one, so we cannot start no this third example test case. So we will return directly -1. Then we are taking this value of n, then we are making this another matrix. Why I'm taking another matrix? Because in generally in software engineering we don't disrupt the data actually. Like if we have this grid, we will not disturb it. If we want to perform any operation on matrix, we will copy it, or we will make one copy and do the operations on that one. We will not disrupt or disturb the original one. So I'm making this mat another matrix, and this is the copy of grid only. Okay, you can do in grid also, but it is not a good practice. Okay, so okay, so we are doing BFS, so we know like queue we have to take. And in queue what I am storing the position of the cell, like I and j, like row number and column number. Okay, so like from the source we are starting. Okay, so source is what, 0 comma 0, right? Then we will mark the source as 1, because we know like if this is 1 we cannot move. So if we will not mark it as 1, then it will return to that point again. So it will like stuck in a loop. So that's why we are marking it as 1. You can also like make one another visited matrix and put 1 there for visited and 0 for not visited. I'm doing like in my way with making another matrix. Okay, so BFS has started. We are initializing answer with 0. Then we are doing the that normal BFS, like we are if we are crossing one level, then we are like incrementing it so that we know like on which level we are. Okay, like in this example I told 1 2 3 4, this is the fourth level, so we are returning at 4. Then taking the size, then size is what size, number of cells in queue currently. So I'm taking every cell one by one. I'm taking the position of I and j, then I am like popping it out as we always do. Then if I'm checking if the I, if this cell is the last cell that I have stored, like from here I am on this, I have stored this last cell, I will directly return answer. Okay, and if we have not reached the target yet, in that case we will like we'll go in all the 8 directions, and we'll check like if this is the valid one and we can proceed. For example, like if the, like for example, I am here, and okay, I am here, and from here like this will check here. So this is not a valid condition, no, you have to check in the matrix only. So the basic condition we have given, like if the thing we are checking is in matrix only, so like then the row should be, just a minute, what happened? Okay, it came back. Yeah. So it, if it is if the cell is, the cell we are checking is inside the matrix, it is like the row is also like correct, column is also correct, and also this cell has not already been visited. So if it is not already visited and the cell is inside the matrix, then we can mark it as one, that means it is visited, and we will push the push this cell to our queue. And all the queues that we are finding, like from here we will push this zero and this zero simultaneously. So like this we will push, and this BFS will work. Okay, and in the last, if we are finding that if we are finding like no possible shortest path is there, then we will return -1. Okay, so thank you guys for watching. Please do consider subscribing or liking it, or if you have any doubt you can comment that in the comment section. Okay, thank you.